Welcome to another video of TECLAB from the College of Engineering and Computer Technology. By the way, I'm Engineer David Pamon. So today we'll be performing experiment on node characteristics of this generator. At the end of the experiment, the student can, number one, explain the factors affecting the voltage generation of a DC generator. Number two, can connect circuit to demonstrate the effect of the speed of the prime mover to voltage generation. And number three, demonstrate the speed of field current to voltage generation. Now we'll be performing experiment using this equipment. Now let's discuss with you. This is the shunt field resistor that we will be using. We have also a DC ammeter here. Then this is a device to demonstrate the no-load characteristics of DC shunt generator. Now this is the prime mover, and this is the DC shunt generator. Now there are the factors affecting the voltage regulation of no-load characteristic of DC shunt generator. Number one, the speed of the prime mover, and number two, the magnitude of the flux. Now, to demonstrate the magnitude of flux, of course, we cannot directly measure the flux. Instead, we'll be using the field ammeter. Then we will connect this resistor to control the field current. Okay, there are two factors affecting the no-load characteristic of this generator. To control the speed, we have here a toggle switch. Then this will control the RPM of our prime mover. So let me demonstrate it. Now we have here the scale for our RPM. To set the scale, we can use this knob, varying the knob. Then you will notice that the RPM changes to it. Now that corresponds to the speed of the prime mover. So on the first part of our laboratory, we'll be controlling the RPM, and we will measure the voltage generated by this generator. Now, under letter B, okay, the second part that affects the no-load characteristic of this generator is the magnitude of the field current using this field ammeter. So, what we'll do there is to set this to maximum RPM. Then we will vary the field rheostat. So, we have here the field rheostat. The field rheostat is connected parallel to the armature. So, by varying the field rheostat, we can control the field current. So let me show you. So let us set this to maximum RPM. Then by varying this field rheostat, okay, we have here the movement of our ammeter. Okay, the second factor affecting the no-load characteristic of our DC shunt generator is flux. Unfortunately, we cannot measure flux directly from the ammeter, but instead we will be using the shunt field resistor connected in series with our field current. Now we have here an ammeter. Okay. Now we'll set this to maximum RPM. Then by varying the field resistor, you will notice that the field current will be affected. So maximum resistance, then gradually we decrease the resistance, then you will notice also that the field current decreases. Effect of RPM to voltage generation. Let us set this to 150 RPM. Okay, the voltage generated by our generator is now, since this is a digital, pulses lang siya. Okay, 1.15. The next is 300 RPM. There was also increase in voltage generated, that is 2.4. Next is 450 RPM. This is the voltage generated, 3.8. Then next is 600 RPM. Notice the change of voltage. It increases to 5.7. The next is 750 RPM. The next is 900 RPM. The next is 1,350. And this is the voltage, 98 volts. Okay, let's proceed now to the second part, the effects of changing field current to generated voltage. Now to do it, we will set this to maximum RPM. Then we will vary the field resistance instead. Set this to maximum resistance, then gradually decrease the field resistance. Now what we need here is to vary the field current as shown by this ammeter. So let us start with 0.1. 0.1 ampere, the voltage reading is 106.7 volts. Now let us change the current to 0.12 ampere, and that is done by controlling the field resistance. So this is 0.12 ampere. Then this is the reading of our voltage generated by this generator. The voltage generated is 114 volts. So next is at 0.14 ampere. So this is the voltage reading at 0.14. 120 volts. And then at 0.16. Okay, the voltage reading is 128. Watching ang video from TECLAB. Please like